time for questions. We got quite a bit of information to go through. Hopefully we can get through it all. What we're going to talk about is, first I'm going to talk about the book itself. It's been advertised that it's a harmonization of the AIAG and VDA method. I want to examine that more closely. We're going to talk about the role of software in the VDA SEMA methodology. What we're going to learn is that this methodology, actually, its origin is back in 1988, and its software has played a key role in the whole process, and it's important that you understand that. Then we're going to get into the AIAG-VDA DFMEA methodology, hopefully in a very short period of time. I think the slides are pretty easy to understand. You'll get a grasp of what this thing is, and especially if you've done FEMAs using the AIAG 4th edition FEMA manual, I think you'll be able to see the difference between this methodology and the AIAG and how you basically move to it. A lot of people, based on things I've heard from AIAG, their advertisements, 75 to 85% of the people currently doing FEMAs use Excel. We're going to look at, what does it take? How did the Excel forms get created, and what would it take to do? If you decide, hey, I want to use Excel to do this, how would I go about doing that? At the end of this seminar, you should understand. We're going to do a similar thing for PFMEA. We're going to explain what the methodology is, how to do it. We're going to explain how to do it using Excel. Now, as we talk about the DFMEA and PFMEA methodologies, we're going to define some of the weaknesses of the method, which, to be honest with you, are considerable. And so one of the topics we're going to talk about is, okay, if I have to do this, if my customer, if I'm trying to be certified and my customer gives me a customer-specific requirement that I have to follow this method, how do I follow this method and still keep doing strong design FEMAs and process FEMAs? And the last topic I want to touch on is AIAG-VDA FEMA training. There's a big rush now to go purchase training, even though we sell training and we'd love to sell you training. I want to explain to you why you might want to wait. As far as is it an adoption or harmonization, in January of 2018, I wrote an article in the AIG in the Quality Digest describing it was called "The Case Against the AIAG-VDA DFMEA." I basically went through and explained the weaknesses of the methodology and how its implementation would lead to basically design FEMAs that were not effective in managing risk. And in response to that, a member of the AIAG-VDA FEMA committee, Mike Bucala from Daimler Trucks North America, made the following statement. Your article concludes that the team should have started with Excel-based AIAG 4th edition FEMA methods and by inference expected the Europeans to modify their software-based methods to conform to it. This is an unrealistic expectation. Well, when they sent out the draft version for review, one of the lines in the draft version said the FEMA method is described by a planning and preparation activity followed by a 6-step process. This is similar to the previous 5-step process in VDA volume 4 2012-3 with the addition of scope definition. Bottom line is this manual is not a harmonization of the AIAG and VDA FEMA methods. It is an adoption of the VDA FEMA method, which is software-based. And you're going to learn that if you want to understand this method, the way to understand it is by learning how VDA software works. As far as a little bit of the history, in 1988, Siemens actually contracted with a gentleman named Peter Rosenbeck to develop a failure diagnostic system with fault tree analysis elements for a semiconductor production process. You can actually probably consider Peter the father of the VDA FEMA process. Although he was created a fault tree program, they called the software itself Object FEMA. And this is where I believe the fundamental flaw in the whole VDA FEMA process is, and that is you're going to see that there's a belief that the failure causes of a fault tree are equal to the failure causes of a FEMA. and they're not, and we're going to teach you that impact. So bottom line is, in '89, Siemens basically put it out for public consumption, and Mercedes-Benz, BMW, and Siemens actually partnered with Rosenbeck's company to take AIAG-VDA to the next level. And what came out of this was a software package called ASQ FEMA 2. It was offered for sale in '92. Now, the interesting thing about this is Daimler-Benz inner services called DEBIS, that's actually an internal company within Daimler-Benz AG, was a distributor and seller of the software. So you had, I guess, the largest automotive company in Europe selling FEMA software, which obviously gave them a leg up on everyone else. Well, from '91 to '96, there was a VDA work group 131, and in 1996, they published VDA letter 4.2, which is System FEMA Failure Mode and Effects Analysis. Inside this manual is the 5-step process that you currently find in the AIAG-VDA FEMA manual. So anybody who says that this is a new technique, it's not a new technique. Now, what was interesting about it was that when it first came out, because it basically pushed the methodology inside the ASQ FEMA software, many people complained that it basically was a user's manual for the software. And it's interesting, if you can get your hands on a 2012 version of the VDA manual, they make in the preface, make the comment that it is pointed out that no special software program was preferred by these representations. The bottom line is the VDA methodology, as Mr. Bucala stated in response to the article that I wrote, it's based on a FEMA software. Basically, it's a description of how the VDA software works. Now, the other interesting thing was in '96, Volkswagen acquired a worldwide site license for FEMA software developed by Plato AG. This is today why the two major players in FEMA software in Europe are Plato Skio and ASQ FEMA. It's because of the relationships with the automotive companies. Well, if we spring forward in 2016, AIG announced the launch of the Core Tools Form Solution Project. And in their advertisement, they stated they wanted to support the release of the new AIAG-VDA FEMA manual. In 2007, they put out the stakeholder review, and inside that stakeholder review, it made the statement, when products and processes are complex, it is recommended that specialized software be used to apply the method. So here we are, we're back again with the software. Now, a lot of people commented back, being that 75 to 85% of the users are Excel-based, they got a lot of complaints. And AIG put on a webinar that Scott Gray gave, and in that webinar, he says, so I want to be clear here that we have tested, validated with suppliers that the methodology can be executed with either spreadsheets, again, typically Excel, or specialized FEMA software. Well, during this presentation today, I'm going to explain to you what this method is. I'm going to explain to you what you have to do if you want to try to implement it with Excel, and you can make the assessment of whether or not you think it can be done. Let's talk about the methodology. If you want to understand the DFMEA methodology, you have to begin by understanding what I like to call the VDA software product fault tree. They talked about before, Rosenbeck, who created this whole thing, he is responsible for creating a diagnostic system. And he's the one who invented this concept of structure analysis, function analysis, and failure analysis. So the first thing you do is, if you want to apply this methodology to one of your products, is you have to define a scope of the assembly, sub-assembly components that are going to be in, that you want to analyze using your FEMA. And this is what we call a structure analysis. So this is a very simple one. We have assembly, we have sub-assemblies of the assembly component, and the very last level is specifications for those components. So once you do, it's basically a graphical bill of material. The next step is to identify the functions of each of those items in that structure tree. So you're going to have assembly functions, your sub-assemblies are going to have sub-assembly functions, your components are going to have component functions, and obviously these components are going to have design characteristics that you're going to have to set specs for. So what you have now is you got this tree, you got each of your components, you got all their functions, and you got the relationships between their functions. The third step is what we call the failure analysis. What you now do is you take each of those functions and you say, how can I fail to meet it? So now I got assembly failures, I got sub-assembly failures, I got component failures, and then at the very last level, I describe the characteristics that I could improperly specify that leads to those component failures. With this matrix, Rosenbeck could basically troubleshoot failures. He could take any failure in an assembly function and quickly drill down to what the characteristics were that were controlling it by basically traveling this path. Why he called it AIAG-VDA, I don't know, but the bottom line is people looked at this and they say, because one of the fundamental mistakes that people make about FEMAs is because of its name, like design FEMA, they think the job of the design FEMA is to identify all the failure modes. It's not. The job of the design FEMA is to assess the risk of releasing the hardware specs and software code if it exists for use. So anyway, let's look at how we take this fault tree and how this fault tree becomes a FEMA. So the bottom line is in this fault tree, you're going to have assemblies, sub-assembly, components, component characteristics. These are known as elements. In this methodology, you must do a design FEMA for every single unique element that is in this tree. Like as an example, in the manual itself, there's an example of a wiper motor. I've done a wiper motor design FEMA. It had, I'm going to say, 45 components. 45, I should say, it had an assembly, multiple sub-assembly, and components, and the total together was like 45. So for me to apply this technique to that wiper motor that I did several years ago, I would have to do 45 different design FEMAs, and they would all have to be linked together. So in our particular case here, if this was our structure, we would have to do 3 design FEMAs, one for assembly, one for sub-assembly, one for component. You do not do a design FEMA for the last level, which is the component characteristic. So the way we use this information, in the book, in the AIAG FEMA manual, they start at the sub-assembly level. So they would say, this is my focus element. So here's your FEMA form. So if this is your element, you take the focus element, you put it in a focus element column, you take the function, you put it in the function column, you take the failure, you put it in the failure column. You get the effect by going to the level above you and grab, You get the effect by going to the level above you and grabbing that failure. So in this case, the effect of the assembly failing to meet its function, of the sub-assembly failing to meet its function, is how the assembly will fail to meet its function. You get the cause by going to the failure below it. So in this particular case, the reason the sub-assembly failed to meet its function is because the components failed to meet its function. So this is basically how you transfer information after you create this product fault tree, how the software transfers this information to the FEMA form. The only thing you do after that is you add these columns, these yellow columns, and these are the columns you now supplement the information from the fault tree with. If we look at, as I said to you before, every unique element in your fault tree in this methodology, you must create a design FEMA for. Since we have 3 elements, assembly, sub-assembly, and component, we are going to have to create 3 different design FEMAs. Now, if we take this top one, you can see assembly. Okay, so we move these columns here, but you see there's nothing above you. And this is where you put the vehicle end user requirement. However, below you is how the sub-assembly failed to meet the function, and that's why you put that particular failure cause as the failure cause of the assembly failing to meet its function. We come down here to the component level, that would be this design FEMA down here. You basically take these 3 pieces of information, You populate the first three columns of your design FEMA. You take the failure above, you stick that in the effects area. You take the failure below, you stick that in the cause area. This is how you transfer information from the DFMEA, the product fault tree, to the design FEMA. I wish I could see you and ask you if you have any questions, but we don't have that luxury here. Let's now take the book. Now, for copyright reasons, I didn't use the wiper motor, but I've done seat motors, which are very similar to the wiper motor. So you actually can pull the manual and you'll see that this is really, really close. So it won't take a rocket scientist to figure out that this very, very, very closely approximates the manual. Well, what they have is a window lift motor. We're going to have a seat motor, and this is an example. This is a cut of their fault tree. And they actually do their FEMA, their example in the manual is on the commutation system of the wiper motor. So here we see the commutation system. Here we see the failure mode. Here we see how they basically take these three elements and they use it to populate the first three columns of the commutation system design FEMA. They get the effect by going one level up. Pardon me. They get up. They get the cause by going one level down. And so now you can see how this, using actual information, and like I said, it's right from the manual, except we're going to do a seat motor instead of a wiper motor. You can see how to take actual information and transfer it to your FEMA. So to be honest with you, if you understand this simple process here, you grasp the fundamentals of the AIAG-VDA DFMEA methodology. Let's talk about its weaknesses. Well, one of the things that happens in order to do a design FEMA, the purpose of a design FEMA is to assess the adequacy of a design before you release it. When I say design, I'm talking design specifications that you're going to give the manufacturing to build to, and software code, in meeting a set of defined design requirements. So that means for me to do that assessment, for me to create a design FEMA, the very first thing we need is verifiable requirements. And one of the things you see in all of these, and a perfect example of it is the AIAG-VDA manual. Another perfect example of it is the 2012 VDA manual, or if you can get your hands on the 1996 VDA manual, you will see examples of design FEMAs that do not have verifiable requirements. Here, if we look at this is a verifiable requirement. We have to convert the electrical energy to mechanical energy according to a certain parameterization. We have numbers and we can verify against those numbers. These next two are just statements. Commutation system transport the electrical current. Brush card body, that tells me what it does. It doesn't give me acceptance criteria for proving that my design works. And the bottom line is, what you're going to see if you look, and I've looked at over the last 20-some years, many VDA many FEMAs created using this VDA methodology, and one of the things they all have is design requirements that are not verifiable. The next thing you see is non-root causes. The bottom line is, what we're trying to do is assess the risk of releasing hardware specs or software code. So our failure causes that we're trying to capture is bad hardware specs or bad software code. And anything that doesn't tell us something about hardware specs or software code is not a cause that we can use. Well, we look at this first one up here and we go, that doesn't tell me anything. That's another failure mode. And yeah, it is another failure mode because we got it from a fault tree. And we look at the next one and we go, that doesn't say anything about a hardware spec. That's another failure mode. We go, yep, can't use that one. And then it's when we get down here, I finally got a spec. I finally have an identifiable potential problem with a component spec. But then when I go over here, I don't have a design requirement to verify against. There's inadequate definition. So the bottom line is, if I look at all three of these design FMEAs that I have just created, none of them can be used to effectively manage risk. And this comes from the fundamental flaw of the VDA design FMEA process, which basically says the failure cause of a fault tree is equal to the failure cause of a design FMEA. It's not. Failure, the only root cause in a fault tree is the last leaf. That's the spec. In the design FMEA, all the causes have to be root causes. So the only allowable entries over here in a design FMEA that can be used to manage risk is a spec and a mistake. The other thing is not all design requirements can be easily transferred to subassembly and component design requirements. One of them being resonant frequency and drive-by noise. There's no way that an engineer is going to be able to take a assembly level requirement of resonant frequency and translate to individual component requirements. The other thing is it requires the definer to define design requirements they would never define. If you want to say that rattle is caused by a loose screw, and you want to put into the FMEA that the failure cause with the specification was the screw torque was specified too low, you can't do that directly. You have to do a design FMEA on the screw first, okay? And so the bottom line is that's what this says, is the designer cannot jump right to the spec. They have to create this artificial layer so they can say what they want to say. And obviously, it's just a waste of time, and it leads to having to say, how do you define a spec for screws that has acceptance criteria? Let's look at Excel. So the AIG has come out and said, originally they said that, hey, you can't, if you have complex products, you can't use Excel. And then they got pushback, so now they've come out and said, oh, we did all this testing, and you can't. Well, let's look at it. Let's look at how you create the Excel. Well, the first thing you have is we begin again with our software product fault tree. We basically, if we're going to follow the VDA methodology, we have to capture the information in this, okay? And so what we're going to do is we're going to, like they do in the manual, we're going to pick the commutation system as our focus element. So the first thing it says is we got to do our fault tree. We got to go seat motor, the commutation system, the brush card body. Seat motor, commutation, brush card body. Then we have to do our requirements, converted energy, transport. We got to put these three in here. And then the next thing is we got to put our failures in. So bottom line is they created an Excel spreadsheet that will allow you to capture the fault tree. But the other interesting thing is these elements in white, these are not required to do the risk assessment of the commutation system. So those of you using Excel are going to be forced to populate 4 columns of the Excel spreadsheet that serve no purpose whatsoever in the risk assessment of the commutation system. So once you create the fault tree, the next thing you got to do is add the columns. And here's how they got to that. So the bottom line is when they created the Excel forms that you find in the back of the manual, all they're basically doing is creating an Excel spreadsheet to capture your fault tree and then adding the FMEA columns. And again, one of the problems with is you're being forced to add a bunch of information that, quite frankly, you don't need to do in order to do the risk assessment. Let's talk about what are the problems when I try to use Excel. So let's assume I create this Excel spreadsheet. I make all the end of the book. What happens when I go to use it? Well, the first thing is you got to link all these FMEAs, okay? This seat motor, this commutation system, this brush card body, they are all individual design FMEAs. In every place where you see the color the same, like in this case here, you got 3 Excel spreadsheets you got to keep linked. And like I said before, in the case of the wiper motor that I did, I think there was 45 components. So now I'd be forced to link and maintain linked 45 different design FMEAs. Impossible? No. Probable? Probably not. Another thing that happens is we put this into an Excel spreadsheet. How do I sort it? You know, here's a case in my normal design FMEA. What I would do is I'd have my focus element, which is the subassembly. I'd have my focus element function right here. And then what would happen is I would have my different failure modes, which is right here, and over here I'd put my causes. But now I got to populate this fault tree. And before I put my cause over here, I got to put my components over here. And then I got to put my component functions over here. And then I can go list my cause. Well, I look at this and I go, well, if I keep my old order, I got to enter this component's function 2 different times. So like before, where I just entered it once as my cause, I got to now make sure that every time I put in this component A function, that I put it the same in every column that I use it. Well, some people will say, well, okay, well, let's sort by component then. Well, now the problem is this component can affect 2 different functions, which leads to 2 different failure modes, which is what I'm really interested in. And now I find that all my causes, my failure modes are no longer grouped together. So I find it very difficult to basically look at all the data and analyze the data visually. So I personally believe that they're going to have to go revisit these forms, because these forms will not work with Excel. Another thing that's going to happen is here we have a case where we have 2 different assembly functions, assembly function X and assembly function Z. And we fail to meet those assembly functions for the same reason, and that is this component function W was too fast. And the reason it's too fast was the width spec, or the potential reason is we set this width spec too narrow. When we look at this, and there's a thing called AP, this new process that replaces the RPN, and unfortunately, I don't have time to get into the AP, but it is functionally flawed as well. It doesn't work. It takes about 15 minutes to explain why it doesn't work. But the bottom line is AP in the new methodology replaces RPN, and based on the severity, occurrence, and detection, you set an AP rating, and this is the order in which you're going to work on things. Well, you see we have the same issue here. We have component W too fast, component width specs too error, component W too fast. Well, this one says it's high, and this one says it's low. Which one is it? Well, what's interesting, if they had just stuck with the old methodology that the VDA has, and actually was back in 1996, you can see they group these effects. And they take the worst case, and in this case, back in 2012, they didn't have RPN. The AP is a new invention. So the bottom line is in this attempt to prove that you can use Excel to implement the AIAG-VDA process, they've actually created an issue where you can't use it. So, I mean, I'll leave it up to you, but I think you kind of, in looking at these slides, hopefully you might see that if you truly have to do this thing, Excel is not a good bet to do it with. So next thing I want to talk about is the process FMEA. Just like the design FMEA, you have a fault tree, but it's a process fault tree. And the big difference between this fault tree and the product fault tree is you can only have 3 levels. In the other fault tree that we went through, you can have as many levels as you want. It basically depends on how many assemblies, subassemblies, and components. In this particular case, you're only going to have 3 levels. The first level is the name of your process path. The second level is the name of each of your process steps. And the third level is the 4M work elements that can affect the performance of a process step, being man, machine, material, method. Some people believe there's 6, you can use 6, but the bottom line is these are the work elements that make up the process step. Just like in the case of the product fault tree and the process fault tree, you have to define what's the function. So what is the function of my process path? What is the function of my process step? And which 4M work elements affect my ability to meet this function? What are the function of those 4 work elements? And then again, just like our product fault tree, we now have to have failures. So we say, how can I fail to meet the path function? How can I fail to meet the step function? How can I fail to meet the 4M work element function? So again, we go in the software, in the VDA software, we populate this tree, and what the VDA software does is this. As I said before, or maybe I didn't say, the only element that you will do a FMEA for in the software process fault tree is the process step. So you're only going to do one FMEA for each process step. You won't do a FMEA on the process path, and you're not going to do a FMEA on the 4M work element. The transfer is identical to the product. So basically, we move the element, the focus element here, the step function here. What's that element have to do, and how can we fail to meet it? We go up to get the effect. We go down to get the cause. So if you understand, if I took you way, way back, if we went all the way back, you're going to see it's the same thing, except now we talk about process steps versus assemblies, sub-assemblies, and components. So what I line, we're going to in process, and you see the function and the failure. The element is the press machine. That's one of the 4Ms. You see its purpose, you see its failure. And so what we see is we take this middle section, the element gets transferred, the function gets transferred, the failure gets transferred. We go one step up to get the effect. We go one step down to get the cause. And this leads us to the seat motor PFMEA example. Talk about the weaknesses. The biggest weakness of this methodology is the most important output of the process FMEA process is the process control plan. The process control plan, especially the prevention controls, control the ability of your process to be successful. And you got to get to a root cause to know what they are. But what happens in this process, we identify a function of the 4M and we say, how can it fail to meet it? So in the case, if we step back, our requirement is we have to press in the centered bearing, and we say, how can it fail to meet it? We stop before reaching the final position. That's not a root cause. We got to ask the question, why did we stop? And what did something wear? Did something fail? Was there contamination buildup? I apologize. You need to get to the root cause here. And one of the things you'll see, start with the AIAG-VDA FMEA manual, start with any of the FMEA manuals out, any of the VDA manuals out there, you're going to see in most cases, there's some cases where they get it right. In most cases, you will see a non-root cause here. They will describe how the 4M element fails because that's what the fault tree tells them to do, and the fault tree automatically populates the cause column. The other thing is linking DFMEA to PFMEA. What happens is, if you think about DFMEA we created, we have individual design FMEAs for each of the assembly, the sub-assembly, and components. And now I have a manufacturing process whose job it is to put all these things together. How do I take all of these design FMEAs and link them to the PFMEA? Bottom line is, I've never seen it done. And if anybody's seen it done, I'd love to see it. And that includes the people who sell this software. So, how do we use Excel to do PFMEAs? Same way we did with product. The first thing we need is, we need to get this fault tree information in there. So we create our fault tree, and we put our 3 items here, Here's our top element, here's our focus element, here's our 4M, then we put our requirements, then we put our failure modes. Again, we see we are being asked to enter a lot of information that, quite frankly, is not required in order to do the process FMEA. Okay? And then the last thing we got to do is just add the columns. So once I get my fault tree information in here, all I got to do is go add my FMEA columns. And this is what it looks like. So you can go to the back of the AIAG-VDA FMEA manual, and you can see that here I kind of crunched the optimization columns together so I get all on one screen. You're going to see this is the methodology. So the bottom line is the way they created a spreadsheet, the Excel form was create a place to put fault tree and then stick the other FMEA columns in, and here's how you're going to implement it. Well, we're going to find out there's problems. And again, our big issue is what exactly is the proper sort order? In a normal process FMEA, you would identify the process step, you would identify the functions of the step, you would identify the failures of those steps, and list the causes. However, in this particular case here, you see that the causes of these same defects, I got the same machine tool, the same machine failure to function, causing two different defects. So what happens is the person doing Excel is going to have to enter this information, in this case, twice. And if this combination were used for 10 other failure modes, they'd have to enter the same information 10 times. So the bottom line is you have a major nightmare, for maintaining it, and a major waste of time, because as you can see, these items are white. They're not required in order to do process risk assessment. Well, some people go, well, let's sort by 4M type. Well, now what happens is when I sort by 4M type, I come over here to my failure modes, and now the causes of my failure modes are split apart. Okay? And again, we're going to get back into our PFMEA AP problem. So the bottom line is that when you try to take a fault tree and combine it with a FMEA form and try to stick it in the same Excel spreadsheet, that is a recipe for disaster, and I don't see how any human being can maintain these spreadsheets. So now you're probably saying, well, wait a minute. So this guy just took the AIAG-VDA FMEA manual, identified all these weaknesses and all these problems, but I could have a customer who comes to me and through an IATF, customer specific requirement, says you got to follow this manual. What can I do? There's some things you got to remember. The first thing is, the most important thing is, you need to create design FMEAs and PFMEAs that are effective for managing your design and manufacturing risk. You do FMEAs because you want better design and you want better manufacturing processes. You don't do FMEAs to meet a manual requirement. Now you got to understand, the AIAG-VDA FMEA manuals have fundamental flaws. And if you use these methods exactly as that manual tells you to do it, you are going to create FMEAs that are ineffective for managing risk. The good news is the methodology has a section called the scope, where you can go in there and you can define rules. We have been dealing with the VDA FMEA methodology since 1996. We have known it doesn't work since 1996, but we have clients who have customers who say, you got to follow this methodology. So the key thing you have to learn how to do is, there is a way that, by making some, and I don't have the time to explain it, by adjusting the scope, that within the scope, you can identify how you're going to slightly modify this methodology to conform with how you manage risk within your company. And in the end, you can get FMEAs that are compliant from a format standpoint, but really weren't done using the methodology. And I have here in bolded point, very important to remember, the auditor is going to audit the compliance of your DFMEA and PFMEA output format with the AIAG-VDA format. They're not going to audit the process you use to get here. This is an example. This failure net was created by FEMAs that were done using the AIAG 4th edition FEMA methodology that have passed an audit, and these people knew nothing then and know nothing today about how the VDA process works. Here is an example of the 2012 version of the AIAG-VDA DFMEA output. Again, this output was created using FEMAs, constructed using the AIAG 4th edition FEMA methodology. There isn't exactly compliant. We do things in here that, we did it exactly the way the VDA wanted to do it. You couldn't get the right entries in here. But bottom line is, auditors look at this and they go, great, you passed. The cool news is we passed the audit requirement, but more importantly, these customers have design FEMAs, have process FEMAs they can use to manage risk with. There's a slide I left out of here. 3 reasons. I said in the beginning I was going to explain to you 3 reasons why you should wait on FEMA training. And the first reason is you might not have to switch to the methodology. If your customers do not come to you and say you have to follow the methodology, and do not come to you and say to you or write an IATF customer specific requirement to follow it, then you don't have to do it. Now what's interesting is FCA, Chrysler, one of the big 3, on July 8th, and you can confirm this by looking it up on the internet, and I apologize, I don't know how I deleted the slide. FCA has already come out and said they prefer that you use the AIAG 4th edition FEMA method. However, if you want to use this new method, you can. That's got to tell you something. Second reason you don't want to jump at training is there may be a second methodology you're going to get to pick from. The SAE, Society of Automotive Engineers, is currently creating a revision to their current manual, and it is not in agreement with the AIAG-VDA. And when this manual comes out for the first time in 18 years, the Society of Automotive Engineers is going to disagree with the AIAG on how FEMA is to be done. And given the influence of this particular organization, I'm just a lowly consultant. There's somebody out here in the FEMA business. I can't guarantee you this, but it wouldn't surprise me that people come out and say, hey, you can either follow the SAE or you can follow the AIAG-VDA, and having some insight to what the SAE is going to have in it, I'm going to tell you that method I think is going to be a lot stronger and a lot more efficient. The third reason is I've explained to you in this talk, is that this methodology, this AIAG-VDA methodology, if you follow it to the letter, you're going to produce FEMAs that take you more time and that are less effective. And that's going to impact your business. And you want to make sure that who's ever teaching you this methodology understands what those weaknesses are. So you can they can be taught how to get around them. But I wouldn't worry about any of that training yet until I know that I have to do it. If you do go ahead for training, I'm going to give you one caveat. AIAG has come out and said it's a 2-day class to teach design FEMA and teach process FEMA. There's other companies who sell training who are just going whole hog trying to sell you VDA training. Some of them are quoting 2-day classes and 2.5-day classes. It does not take 2 days to teach this process. anybody who can't teach you this process in one day doesn't understand the process. So hopefully you'll never have to purchase that training from them or us. We could give the training now, but we've chosen not to do so. We're going to stay back, okay, and wait and see if people are forced to do it. And if they're forced to do it, we're going to help them. But hold off. Don't spend your training dollars. Don't go out and buy software in order to implement this thing. You'll have plenty of time to do it. So as a conclusion, the DFMEA and PFMEA methodologies contained in the manual are fundamentally flawed processes. And if you follow them exactly, your DFMEAs and your PFMEAs are going to get weaker. Due to the VDA members on the committee, their refusal to give up their software-driven FEMA methodology, which says fault-free failure causes equal design FEMA failure causes, it is impossible to fix this methodology. They literally have to give up that software methodology, and they've already shown they're not going to do it. When it comes to Excel, unless you have single component products and simple processes, I believe you're going to find Excel will be extremely difficult and inefficient in implementing this method. As I said before, wait before rushing out to buy software training. And then finally, if you got to comply with it, you're going to have a unique challenge. And that is, you got to figure out how to create FEMA output that is sufficiently compliant with the handbook to pass an audit while not using these methodologies that keep you from creating strong FEMAs. So with that, I'll open it up to questions.
Thanks, Rich. You want to put your last slide up so that the audience can see your contact information? And for the benefit of our audience, you will go to this website in order to get a copy of the recording after Rich edits it and puts it up. And the slides, I'm guessing, are going to be available pretty soon. Any questions? I don't see anything yet.
Any questions?
We still have 171 people online. If you have a question, put it into the question panel, and I'll pose it to our presenter on your behalf. I don't see any questions coming up, Rich. I guess you answered all the questions in your presentation. So in that case, we'll probably end the presentation here. And again, if you have any further questions, you can either call or contact Rich directly through his email. And Rich, we'll hope you come back soon and do another presentation for us in the near future.
Thank you for your time. And like you said, Dave said, if anybody has any questions, feel free to contact us.
Oh, there was one question before we go, and that was, when will the SAE method be presented?
That question was asked at the conference. My guess is it's still going to be a couple months. There's a lot of, there's people from the AIAG-VDA committee and the SAE group, and so they're having some interesting discussions. I would expect it's going to be by the end of the year. And I think what's going to happen, again, this is all conjecture on my part. My guess is that the big companies are not going to make a move in terms of telling you, I could be totally wrong, of what FEMA methodology to use until that manual comes out. Because like I said, for the last 18 years, the SAE and AIAG have been technical equivalents of each other. They are not going to be when this manual comes out.
Another question showed up. Where is the FCA quote? Do you know what the URL is for that?
If you want, I can get it right now. You want me to do it?
Sure, yeah.
Actually, okay, here. Let me, where's this?
clicking away over there. One of them was, is the AG or the AIAG process for me?
The answer is there's some issues with it as far as my personal opinion is you're 100% better off going with the 4th edition than you are with the new methodology.
And there's a question here to ask, why do we need approach?
Here's the problem that we have. The problem that you have with the global approach, think about what they're doing approach to AIG online or in the automotive industry. You would never build a manufacturing process and then after building the manufacturing process, decide what kind of product you're going to make with it. You would decide what kind of product you're going to make, then you'd build the process. What they're doing with this handbook is they started with the VDA saying, this is what we're going to do. We got to appease the Excel people. What can the form look like when we don't give this up? Okay? So I believe, when it comes to harmonization, then if you read this article, go to Quality Digest, I believe you could harmonize on the form. There's key elements that a FEMA has to have in it. And if people would agree on what they were, I think everybody's FEMAs would get better. But what you can't do is force people to use a method. And the problem you have right now is the methods that they have, especially in Europe, this VDA software method, it cannot properly populate that risk form. And so as far as harmonization goes, I think it's a loser for North American automotive to try to harmonize. Unless they want to harmonize the form and let people get to the right result however they want to do it. I'm going to try this one more time. I think what I'm going to do, I can't figure out how to do that. You want to go to the IATF website. There's an area called Customer Specific Requirements. And you want to look for SE, and you click on this first item here. And when you do, you'll be able to find that you don't have to do it, but I can't
buy that one.
I don't know anyone who recommends that.
Yeah, it says it seems like in the process for me. Do you agree?
It's actually easier to work around, make it bigger.
No, it looks.
Preparing AIAG potential failure modes and effect analysis FEMA. The AIAG-VDA failure mode and effects analysis design FEMA and process FEMA handbook may be used. Okay? PFMEAs. Organizations preparing FEMAs should follow the AIAG FEMA. The AIAG handbook may be used. So what they're saying is, when you use that handbook, okay, but we think, the way I read that, we'd like you to use the AIAG 4th edition methodology. That's the way I read that. And I think it's pretty telling. I know people in FC. Interesting that during this conference, it was a pretty wild conference. There was 8 people there, and there were 3 of us who, obviously there were people on the committee pushing it, and there were 3 of us saying, no, stop. There's issues with it. And it came out that the final version, the original final version, all the big 3 shot it down. And then there was some meeting that nobody knows what happened during the meeting, and that manual ended up being approved. But there's a lot of experts in that I believe understand FEMAs who are dead against this methodology. Any other questions?
No, I think we're going to have to stop here, Rich. We're past the hour. So again, I'd like to thank you on behalf of our audience, and thank you on behalf of the ASQ Reliability Risk Division for presenting today, and hope to see you in the future doing another presentation soon.
great, Dave. Thank you.
Thanks.
I appreciate
We'll end
it.
here.
If anybody has any questions, you got my contact info. Feel free to send me an email, call me on the phone, whatever. As you can tell, I'm pretty passionate about this stuff.
Thanks again.
And try to get other people. We got to educate. You know, if you liked what you saw, we got to get the word out, because that's the only way we're going to prevent this thing from, I believe, harming companies. All right. Thank you very much.